Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to look at this application question on differentiation. We are told show that V equals to 3R minus pi R cubed. And if you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload an tutorial, you'll be notified. See you in the next. Now, something that we need to remember is that here we are told that we are supposed to show that the volume of this cylinder here is given by V 300R minus pi R cubed. And also we are told that the surface area of this cylinder is 600 centimeters square. So something that need to be in your mind is that whenever this cylinder is cut and we have a net section of this cylinder, bottom and the area of the top. So meaning that our surface area is going to be 2 pi r h, because this is length times width. This is 2 pi r because this is the section that goes around the curved part when we are having this cylinder here. So which means that for us to find the area of this curved section here, it will be length times width, which is going to be 2 pi r times h. Then we're going to add the area of this circle and the area of this circle, which forms the bottom and the top of this cylinder. And this is going to be area of a circle is pi r squared. And since there are two, we are going to say 2 pi r squared. Now this is going to be our surface area, and the surface area is equivalent to this value that we are given here, which is 600 centimeters square. So meaning that we can say that 2 pi r h plus 2 pi r squared is equivalent to 600. So which means we can be able to say 2 pi r h is equals to 600 minus 2 pi r squared. The reason I'm doing this, I want to find what's the value of h, so that I'm going to use it to find the volume, because in this volume you can see we don't have any h in that case. So this is going to be, if I divide by 2 pi r all through by 2 pi r, it means this and this will cancel out. Our h is going to be, if I divide here, I'm going to get 300 over pi r in this case, minus this one here, we're going to have minus r there, minus r. So our h is 300 over pi r, okay, then minus r. That is the value of h. Anywhere we are going to have h, we are going to substitute this particular part. And remember, volume of a cylinder is base area times height, which is pi r squared h, because the area of the base is basically a circle, which is going to be pi r squared. So which means that our volume in this case is going to be V is equals to pi times r squared times h, but our h is basically 300 over pi r minus r. So if we are going to substitute here, you can see now our V is going to be, if you multiply this part with this, r will cancel out, we shall remain with 300 r, and this is going to be minus pi r cubed. And now this becomes the value of the volume that we were supposed to show at this given point. The next question, use calculus to show that the exact value of r for which V is maximum is this. So we need to find the value of r for which the volume is maximum. remember, for maximum or minimum volume, you are going to do dv dr. So we are going to differentiate this. We are going to say dv dr is equals to 300 minus 3 pi r squared. For maximum volume, we are going to differentiate, but for maximum volume, dv dr must be equals to 0. dv dr should be equals to 0. So meaning this part that we have differentiated, we are going to equate that to 0 in that case, and we're going to say 300 minus 3 pi r squared should be equal to 0. Then what are we going to do that at that point? We are going to say, if you take this on the other side, we shall remain with 3 pi r squared is equals to 300. Yes, and at that point you can see, if you divide by 3 pi, divide by 3 pi, you are going to have an equation r squared is equals to 300 over pi over 3 pi. This is going to translate to 100. So our final answer in this case, we are going to say r squared is equals to 100 over pi. So meaning, to find r, you need to find square root both sides, which means our r is going to be square root of 100 over pi. 100 over pi, which we were supposed to show. We were supposed to show that the exact value of r for v's maximum is basically this part that we have here, and we have shown that. Now we are supposed to justify that this value of r gives the maximum volume. How do you justify? How do you justify? In order to justify this, you need to find the second order derivative. If you find the second order derivative and you realize that your value is greater than 0, it means that's the minimum volume. If it's more than 0, that is the, let me repeat, if you find the second order derivative and you find d squared v over d squared v dr squared, if you find is greater than 0, that is the minimum volume. If you get less than 0, it means that's the maximum volume. Now we need to justify that this r gives maximum value. So we need to arrive at a point where we have dv squared dr squared less than 0. Let's check whether that's true. Our gradient function, our dv dx is equivalent to what? This point here, which is going to be 300 minus 3 pi r squared. That is the gradient function dv that is dv dr. So in order to find the second order derivative, it's going to be d squared v our dv dr in this case is 300 minus 3 pi r squared. In order to justify this, we need to find the second order derivative, and this is going to be d squared v over dr squared. This is going to be, if you differentiate this, it will run to 0, and this is going to be minus 3 pi r squared v dr squared. We are going to substitute the value of r at this given point, and this is going to be negative 3 pi square root of 100 over pi. Now you can see the answer we are going to get is a negative value. If you do dv squared, d squared r, d squared v, dr squared, and you find it's negative, it means that's the maximum volume. And this is going to be, since d squared v over dr squared is less than 0 because it's a negative, therefore r gives maximum volume. Now, in the next question here, we are told the cylinder now is melted, and the next question here, we are told that a cylinder is melted into a sphere, and of course, of radius p centimeters. We are supposed to find, correct to 1 decimal place, the greatest value of p. So something that really we need to remember at this point is that volume of a sphere is 4 over 3 pi r cubed, because the volume of the sphere is going to be equal to the volume of the cylinder, because this is melted to become this. So we are going to say volume of a cylinder is equal to the volume of the sphere. So we are going to say this is going to be 4 over 3 pi p cubed is equals to the volume of the cylinder, and the volume of this pi r, in this case our r is square root of 100 over pi, and this value is cubed. So which means that in order to work out this, we are going to say is 4 over 3 pi p cubed is equals to what? You can put this in your calculator in order to work out what this part will be equivalent to. 300 root 100 over pi minus pi into bracket root 100 over pi, and this is raised to power 3. If you work it out, you are going to get your answer as 1128.38. 1128.38 at this given point. Then our p cubed is going to be 1128.38 divided by 4 over 3 pi, divided by that answer divided by 4 over 3 pi. That becomes, our p cubed is equivalent to 269.38. Then we find the cube root. We find the cube root both sides. Our p is going to be equals to 6.46 centimeters. And if you have gotten value from this particular video, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. See you in the next video.